So today's coding challenge, or lesson should I say, is a relatively simple one actually, which is given this formula v equals 4/3 pi r cubed. And basically what is this formula? It's a formula for the volume of a sphere. So the Greek mathematician Archimedes is credited with discovering the volume of a sphere. He provided a rigorous proof of his work on the sphere and cylinder, published in 2 volumes around 225 BCE. So we're something like two and a bit thousand years later. And I'm going to do the same thing in Python. It's relatively trivial and easy to do, but nonetheless, it's quite a nice one to have. So what I'm going to do is start with a little block of code, and basically we're going to make a function to calculate the volume of a sphere. So let's just define a function, and we're going to call it something like volume of sphere. So I put of sphere, just like that. So let's name our function something like this. It's relatively convenient, and we'll annotate our docstring in the function to say calculate the volume of a sphere given its radius. And on top of that, we will have some arguments. So our first argument, our only argument really, would actually be r, which is a float, and it is the radius of the sphere. And in saying that, our argument needs to be fed in here, so r, and it's of type float if we are type hinting or type annotating. Now the next bit to do is actually do the computation itself, and I'd need to get pi in some way. There's a whole bunch of different ways that we could do pi. We could say that pi equals, if we were engineers, we'd just say that pi equals 3.14, and that would be good enough. We might even say that pi equals 3 if we're an engineer. But one way that we can do it is by importing the math module. So let's just do that. We'll import the math module, and inside math we'll have math.pi, and that should be sufficient for giving us pi, and we could even see how much that would actually give us. So let's just do that to start with before we even do the actual computation. So we can say something like r for result is equal to volume of sphere. Notice we get this nice docstring that's created, and that's because we've written a docstring over here, and we can see that r is of type float, and it gives us back, well, we don't know what it gives us, but and it actually saying it gives us back, interestingly enough, it gives us back a none, although it's not shown in the IntelliSense here, but if I hover over it here, we can see it gives us back a none. So we take this volume of sphere, and we actually want to then in that case return, we'll just say our volume at the moment is math.pi. We know that that's not the case. We have to do a little bit of extra work, but we can return v, and now what's returned back is a type of float, because Python automatically recognizes, or at least the linter picks up the Python and knows that v is going to be a float because math.pi is a float. And for now, we're just going to put in a dummy variable of r. So let's just put in, we can put in any number that we like. It's not being used at this point in time. And we can print out our value of r. So I'll actually do print r just for the sake of it. That's our result. In fact, I'm just going to write result because it's a little bit clearer. And that's our resulting volume. So when we run it, we can see that we get 3.1415926 and so forth, continuing on. So that's what math.pi does, but we want a little bit more than that because we want to achieve the 4/3 times by pi times by r cubed. So let's just amend that, which will be V, the volume, is equal to, and in fact we could be quite explicit with this, we could say that volume is equal to the 4/3 times the pi times the radius, and then we are going to square the radius, so 4/3 pi r cubed. And that's basically all that we need to do, and this bit here will now turn into volume, and we could say that we return a float which represents our float there, and then the volume of the sphere. So that's basically it. Again, when we hover over it, we see this nice like type hinting. I was just wondering if I could put that in brackets and if that will still work. Yes, it does. That's fine. So we're returning a float and it's the volume of a sphere, but we already see that from the from the function signature, and that should be sufficient. And now we're going to get 100 squared because r squared. We're going to multiply it by pi, and then we're going to do 4/3, which is exactly the volume of a sphere. So let's just run this particular thing, and here we go. We get the volume of this sphere is 41,887 of whatever units we are using. So say for example that r was a radius, then this would be r was a radius, but it was measured, its units were measured in meters, then this would be 41,887 cubic meters, which would be an enormous amount of cubic meters. And if it was like 1 centimeter, it would be or sorry, if it was 100 centimeters, the volume would then be 41,887 cubic centimeters. So that's basically what it is, and we can just change our argument here. The argument here represents a radius, so we could say that the radius is just 2, for example, and we get that. We can say that the radius was 1. And therefore r squared is just this, and all that's happening here is if the radius is 1, and we could test our function here, r squared is going to be 1, then we're going to multiply that by 4/3, and we're just going to multiply that by pi, and that's all it is. And we could do that on a calculator on the side, and in fact I might pull up a calculator. So putting the calculator in just to test that, we would do 4/3, and then we're going to multiply that by pi if we've got a pi over here, which we do, and it comes to the same answer. So that's basically it. Something that was created 2 and a bit thousand years ago, we can now code out in our computers and do all kinds of calculations with this, and use it in all sorts of useful ways. And Python is an excellent language for doing this kind of thing in, because we get nice clean doc strings and nice clean mathematical notation. So that's basically it. That's the volume of a sphere in Python. If you like this video, if you found it useful, hit the thumbs up button, hit the follow, hit the like, and even if you didn't like it, still hit the thumbs up, follow and like. And that's it. Thank you.